Welcome to everyone on board this evening. I'm Roy Crawford, and Kurt Weiss and I will try our best to answer all your questions about forensic engineering sciences. I hope you can understand my accent. I'm in southeastern Kentucky. I'll try to keep it under control as best I can. Forensic engineering, you've probably heard the word forensic kicked around a lot over the last few years, and in our case, it is the application of science, mostly the laws of physics, to law, to legal issues. When people disagree on how something happened, some kind of failure, then a lot of times we can figure out what happened. We're also commonly involved in civil or criminal litigation, where consultants or experts are often called in to assist the investigation during the lawsuit. And as such, if we are required to testify about what happened in an incident, we're the experts are the only kind of witnesses allowed to testify other than eyewitnesses. That's kind of an interesting factor. Otherwise, you have to have seen a crash or heard it or have some personal direct contact. But with us, we can go out and take the physical evidence and do calculations and give our opinions on how it happened. The American Academy of Forensic Science has the engineering science section. It includes engineers of all types, plus scientists of many disciplines like physicists and metallurgists, whose expertise is often valuable in forensic analysis. One thing that makes our section a lot different, and the people in our section, is that you can't get a degree anywhere that I know of in forensic engineering. Usually what happens, the way forensic engineers come to this kind of work, is by getting a degree in a regular field of engineering and establishing a career, and at some point you may be asked to figure out why or how something happened. Having a degree that it's accredited is very, very important, because you'll probably want to get licensed, and I'll talk about that in a minute. Unless an engineer plans to go on and do research or teach, they normally just get a Bachelor of Science degree and go to work. And for the scientists in our section, now many of them do have advanced degrees, a lot of PhDs and so forth. Professional licensing and certification are very important because they prove to the world that you have experience and competency, and you've met at least a certain level of education, and you've done years of work, hopefully without any problems or complaints, and that sets you apart from people who are not really qualified or people who don't have enough experience, that kind of thing. Now, not every engineer has to get a license. A lot of people get their degrees and go to work for a big company and never have to get licensed. But if you're going to be in charge of big projects, if you're going to assign the design for a bridge, for example, there has to be an engineer who is licensed who will take responsibility for that. And that's done by first taking the engineering training exam, and usually that's soon after you graduate college. And then you have to work at least 4 years under a licensed engineer. After that, you take another exam that's very specific on your particular branch. The first exam is more general. It covers pretty much all the science you learned in college. But the second one is, again, it's very specific. Now, to join a professional organization like the AAFS, you have to apply and list references of other engineers who are familiar with your work, jobs you've performed, what your educational record is, and so forth. And there are other organizations like the National Academy of Forensic Engineers that also requires prior membership in the National Society of Professional Engineers. And to join that one, for example, you have to have at least 5 instances of having given sworn testimony. In other words, you have to be accepted by a court as an expert. And sometimes that's the highest hurdle. If you join the AAFS, which you can do as a student, you can participate by attending annual meetings, writing technical papers and presenting them, volunteering for committees, and running for office. And that's a good way to get continuing education, because they have workshops and seminars and so forth. And that's basically how I learned to do forensic engineering. was by reading books and going to seminars. Now, back to what I was talking about before, say you were a civil engineer and you designed bridges for a long time, got to be well known at it. Somebody could come in someday and say, you know that bridge that fell down in Minneapolis? You think you could figure out how that happened or why it happened? And it could be a lot of reasons. It could be a bad design, or it could have been built with the wrong methods by the construction company. They could have used deficient materials. The bridge could have been misused by, say, allowing trucks that are too heavy, or it could just be so old that it should have been replaced. And if you really know your job, you can probably figure that out. And if there are lawsuits involved, you may have to go and give testimony. And at that point, you're doing forensic engineering. There are many subspecialties. Kurt and I do traffic accidents, but there are people who specialize in fires and explosions. We find out who caused environmental damage. We have people who reconstruct airplane crashes. You heard about the train crash in New York City just the other day. It may be people from our section who are working on that, maybe people Kurt and I know. But I guarantee that there are forensic engineers working on that, as well as the crash that the young actor died in out in California a few days back. So there are building failures like let's see, a balcony that fell in the Kansas City hotel many years ago. That one was figured out by some forensic engineers. A couple of examples. One of our members, Steve Batterman, reconstructed the 1988 bombing of the Pan Am Flight 103 over Lockerbie, Scotland. And when he gave us our technical paper on that, he included a lot of details that were really interesting, especially from a technical viewpoint. And there were things that you didn't get in the news. And one of my cases, I solved the 50-year-old mystery of the cause of the worst traffic accident in the history of the country involving children. Now, most of forensic work is related to civil cases, which means somebody is suing somebody else for doing something wrong. And a forensic engineer is not needed unless people disagree on the cause of a crash. If it's obvious, they don't need us. And sometimes there are experts on, usually there are experts on each side who disagree, which can happen even with good, honest people. So we're normally hired by trial lawyers to help resolve civil lawsuits. In some cases, there may be forensic engineering required in criminal cases to prove whether or not somebody broke the law. Now, how do you get a job? If you're a well-known expert in your field, the forensic work will usually find you. It's usually a lawyer who gets a case, realizes he needs an engineer to prove how it happened. He'll ask around who's good, who's qualified to do this, and they may eventually call on you. Also, another way is that you can apply for jobs with companies of forensic engineers and related sciences, or just contact trial lawyers and let them know you're available. Typical day's work, some of our work is outside, some's inside. For Kurt and I, we may go to an accident site and look at skid marks, measure them, photograph them, look at where somebody ran into a tree or guardrail. We may go to the vehicles and measure the crush and figure out which can be used to determine how fast vehicles were going and where people's bodies impacted the inside of the vehicle, things like that. We also have to read, back in the office, we might read police reports, talk to witnesses, might have to do some research, and usually some calculations and sometimes testing. And then normally we'll have to give a deposition, and I don't know about Kurt, but in my cases, probably 95% of the time, if I give a good deposition, then the case will be settled and there's no trial. The personal attributes that a good forensic engineer needs are a love of science, because you got to know your physics and lots of other kinds of science. You have to be good at mathematics to apply all that. You have to be good at interpersonal communications because you'll be interviewing witnesses. and talking to lots of other people, and you may wind up on the witness stand where a jury and a judge are paying attention to how believable you are when you present your information. So you have to have an analytical, fair mind. And something that's different about a forensic engineer and a lawyer is that the lawyer is supposed to do whatever he can to help you win your case. With an engineer, it's not that way. We're supposed to call them as we see them. In fact, that's in our code of ethics. So I've had cases where I've had to tell my client that I don't think the person they want to sue is at fault. Sometimes even my client's at fault. And that's just, you have to be like an umpire in a baseball game. You just have to call it the way you see it. On the plus side, the work is very interesting. It's like detective work, but you don't get shot at. You're using your brains. You can just about always find a job and make good money. Some of the downsides of it are dealing with the legal system and sometimes having to maybe change a vacation. The first time I ever testified in a forensic case, I had to move a vacation to make the court date. Then you're going to have lawyers who are going to question you very, very closely on how competent and honest you are. You got to be able to handle all that. Now, I went online and tried to find current salaries for forensic engineers. They're all over the board because of so many factors. And what I found was usually in the range of about $60,000 to over $150,000 per year. And you can go online and do a Google search and hopefully come up with more up-to-date and better information. Forensic engineers will usually be members of their core professional associations. For example, a civil engineer should be a member of the American Society of Civil Engineers. But once you start doing forensic work, you should join the American Academy of Forensic Sciences and possibly the National Academy of Forensic Engineers. The reasons for that, well, let me say this, that our engineering and sciences section is a place for scientists who do this kind of work, whereas as in the National Academy of Forensic Engineers, it's only engineers, and it's only engineers who have licenses. So a scientist, a metallurgist, or a physicist, like we have, wouldn't be able to join that other association. And these associations are really good for finding jobs in the first place, and also, especially in keeping up with advances in one's particular field. When you come to a conference every year and hear technical papers on an unusual case or a new technique, it's something you can take home with you and learn to do yourself. And you don't have to wait until you're a graduate and experienced and all that kind of thing. Students can join the AAFS and reap a lot of benefits from membership. So that's all I had to say right now, and if there are questions, y'all can fire away. Kurt, do you have anything you want to add to all that?
Wow. Trial experience definitely is just like it is with you. 95% of the time it goes as far as deposition, and the case would settle prior to going to trial. No, I think you did a fair job of describing it. And essentially, I think my takeaway from the conferences is there's always going to be some little nugget of information that you hadn't expected that you can use for years. And that's one of the reasons I continue going to the conferences, is just that networking potential and sharing knowledge. Not just my field, but of course we're there to listen to the other scientists as well. So it's a good round environment to share information.
Yeah, I've always said that just who you sit next to at lunch is as valuable as the technical papers you hear, because you learn a lot of things that way, especially from the older guys. And sometimes you may hear a paper on something you don't think you'll ever get involved with, but then maybe 3 months down the road you have that kind of case offered to you, and then you at least know who to call to get help.
We have a question here about how we got started in our field. And Roy, you touched on that earlier. You attain your degree of choice, you find a job, and you work for some time. And if you're an expert or very knowledgeable in your field, somebody will come to you and ask for a forensic analysis. Or you might go to work for a forensic engineering establishment, and that's the path I didn't choose, but it just turned out the way life works sometimes. I found my current employer before I graduated college, and it was on a personal level, but then he asked me to work in the office to fill a hole. I think I proved to him my work ethic and the long hours and my ability to work hard for the company, and he asked me to fill in. And from there, that was 27 years ago. From there, it turned out that I chose this as a career, and it has been rewarding. And I enjoy Mondays. Mondays for me are exciting because each case is interesting, and that's what it's all about. It's take a personal interest in trying to find the answers of provided some detail that the details of every case are different. So you get a new set of rules, a new set of information each time you are handed a case file to look at. And that's what, for me, continues the interest that I have in this field. Studying car crashes, but even just car crashes alone are so different to classify them as a planar intersection type crash or a multiple rear end collision where all vehicles are in line. There's rollover type crashes. There's vaulting or flipping, or an infinite number of types of crashes. I mean, the details are mind-boggling, and each one is always different, and that's what makes it interesting.
Sure, but because of where I live here in southeastern Kentucky, where we do a lot of coal mining, a lot of my cases involve overweight trucks. So I've had to become an expert in trucks, especially overweight trucks, and some of the problems that they create. And the way it started with me, my license is actually in coal mining engineering, and at some point I was asked to do a simple case, maybe just calculating speed from skid marks, and that's easy to do. So I got the equations and calculated that. And once I did that and word got around, I got another case that was a little more complicated, and I got more equations and went to seminars, read books, and I only took the cases that I felt like I was qualified to do, and they got more and more complicated over the years, and that's how I got into it. And I quit advertising years ago and just go by word of mouth now. We have any other questions?
Yeah, there's one about do we ever go to the scenes of the incidents or conduct investigations? And that's, I guess, a two-part question. There are many engineers or mechanical engineers in the field of collision reconstruction, but there's also the investigators on the law enforcement side. And the law enforcement personnel are those people who get a chance to see the vehicles on scene, and most likely the parties who were involved in the collision in their vehicles, oftentimes and sometimes just at the scene. But it's those first responders that get to see the vehicles at their point of rest and get to see the evidence when it's freshly created soon after the collision. So the law enforcement folks get a leg up on us engineers who are presented with copies of their reports and photographs that they've taken perhaps as 1 or 2 years after the fact. And we're almost playing catch up, but that's part of the research. You have to research the particular collision. And so oftentimes we do go to the crash site. And if we're lucky, there will be tire evidence still on the pavement, perhaps on the shoulder area. That doesn't get a lot of traffic flow, so it has a tendency to erode or deteriorate over time. And oftentimes we see gouge marks if it's a sufficient enough crash to cause the vehicle undercarriage to strike the roadway. that'll give us a gouge mark on the ground. If it's a tread disablement type of matter, you might see a long gouge mark from the rim as the vehicle exits the roadway and goes off onto the shoulder. So we do look for evidence, and sometimes it's there, sometimes it isn't. But and other times we go to the crash scene just to look at the geometry of the roadway itself. Certainly we can use a Google image or an aerial view to look at it, but the scale and the size it's hard to get a feel for unless you actually go on the actual roadway. And the other thing you can't get in say an aerial view is any kind of slope or super elevation on the roadway. So measuring the geometry, it gives us the vehicle headings prior to impact. That's all valuable information that can be obtained by actually going on scene to the crash site.
Yeah, I would say I always go to the accident scene, and there have only been very few cases where I didn't even think I needed to because of the type of crash it was. But even then I go, because if I go to trial and testify and an opposing lawyer asks me if I went to the scene and I say no, then he's going to make a big deal out of that. Even if it's not important to the case, he will make a big deal out of it. So I hate to spend the client's money to take the trip when I don't think it's necessary for forming my opinion, but it is necessary to prove that you've done everything possible to get all the information you can. What's the next question?
Oh, there was a question about describing a typical day. What's your typical day like? And I don't have a typical day. My days are, 3 days of reviewing deposition transcripts or looking at a new case file, and then I get antsy. I need to go out in the field, so we'll set up a vehicle inspection or a site inspection. We mentioned early on in one of the slides about forensic testing, and while all the engineers in this field love to do testing, sometimes the case budget doesn't warrant applied testing because it is expensive and it requires a laboratory and some expensive tools. You either have them or you don't. That's lab time and other fees associated with it. It really depends on the nature of the failure that one is looking into, but we all like to do testing, and that is a whole nother area that's exciting. But again, every case can't budget some sort of test. And that goes back to the previous comment I have, where the details of every case and every crash are different. There could be a unique failure in one car, but not another. And that's something we'd like to look at, but oftentimes the budgets just don't allow for that. In my particular area, the company I work for, we only look at the performance of seatbelts and airbags with regard to mitigating injury for vehicle occupants. That and reconstructing the crashes so we can determine the collision severity, because that oftentimes gives insight into the crash, whether it's survivable or not, or if the injuries are commensurate with the crash severity. We definitely want to know, first of all, how severe the crash is, and then we look at the performance of the safety systems in the car to assist the occupants in mitigating their injuries. So that's a niche in this whole industry of crash reconstruction, is really the performance evaluations of safety systems.
Yeah, when I start working on a case, a lawyer asks me what I want, and I tell him the police report, photographs, any statements by anyone involved so far, and by starting off reading the police report and looking at photographs, then I can start a list of things I want to see at the site, things I want to see on the vehicles, people I want to talk to. And when it gets to the point where some of the people involved have given depositions, especially the opposing expert, I want to read those. And it's interesting. There's a lot of psychology involved in that, because even honest people are often mistaken, sometimes even your own client, especially about the laws of physics and times and distances and things like that. So whatever someone says is something you need to check out, but it's not something you can take as gospel. You can't just go in and repeat what somebody told you unless you can back it up with physical evidence. So as all those things develop, as I go out and look at things, measure things, and do calculations, that brings up more questions, and I just keep plowing through it until I think I've got every question answered, until I think I know enough to form a good, solid opinion. And then it comes to giving testimony. And that's when you've got to have everything ready, all your thoughts prepared, how you're going to back up everything you say. And you've got to be willing to sit there at trial sometimes and with the man that you think is at fault sitting there in front of you and say, yes, I think that's the guy who's at fault. It's tough sometimes, but that's the process I go through. Sometimes, as you know, Kurt, it takes a long time because the legal system moves so slowly. You might do a couple days work and then sit for a couple months, or work on other cases for a couple months before that one comes back up.
Right.
What's next question?
Another question here is, does the Ntsb or other government agencies employ forensic engineers? Well, I know the Ntsb employs engineers. I'm not sure if it's forensic engineers. The Ntsb is, all they do is investigate and recommend changes be made. I don't think their recommendations are enforceable. I used to know somebody who was in the Ntsb, had attended a few of the training courses that I did. He worked on several of the large car crashes, published in the Society of Automotive Engineers, and his work was much like mine, but I don't recall him being able to testify, or he never related to me that he did. So I would say they're more investigators, maybe engineering type degrees that offer a suggestion on how to solve the problem. And this comes up recently on that train that hopped the rail. Speed was too fast for the turn, and there's plenty of factors involved, but Ntsb is going to publish their report with their conclusions, and they're going to make a recommendation for sure on what they think should be done in the future to make it safer.
Yeah, my understanding is that they investigate every plane crash, train crash, or maybe if there's a certain type of accident that happens with cars because there's something wrong with a certain brand or model, that kind of thing. And I think they do basically the same kind of work we do, but instead of being involved in lawsuits, they will try to have changes in the laws and regulations to keep it from happening again in the future. And I know they're working on that train crash. Like you said, we know it was going too fast, but we don't know if the engineer purposefully or neglectfully let it go too fast, or if the brakes failed, or what it was. You know, there was another bad train crash in Canada just a few months back, and I think that was a case where the train was left unattended, and I guarantee you that there's already been a rule in place that can't happen anymore, especially when you got a train that's that dangerous. And that one, the same thing happened. It was left unattended and it started rolling. This is my understanding, and it eventually hit a curve too fast. But not because somebody was taking it too fast or the brakes failed, but just because nobody was there and something happened to the brakes and it started rolling. So I hope that answered the question about the Ntsb. That's probably something that could be learned more about by going online, doing a search.
There's another couple of questions here. I'm going to have to play catch up, but do you often need to recreate the events in question, either through computational simulations or experiment? No, it's not necessary in every case. It goes back to the testing we'd all like to do. Oftentimes it's not necessary. Simulations, for me, it depends on the type of crash. If it's maybe an inline rear impact or a simple intersection type crash, hand calculations is sufficient. If it's more detailed, where there's initial contact between the two vehicles and then there's, say, some rotation and they strike each other again towards perhaps the back, and you want to validate that, you want to validate what you see in perhaps the physical evidence, a paint transfer or a dent towards the rear of the car, which doesn't really make sense, but for the vehicles hitting one another after the initial impact, one could simulate that, and there's plenty of software and tools out there to do it. Experiments could include tensile testing on seat belts to see if the components failed at a load or force value less than what's specified in a federal regulation. That's come up before. The improvements made in seatbelt assemblies have really thinned out the need for forensic testing, at least in the cases I've seen. But in the past, we've done quite a bit of I guess, laboratory testing on seatbelt components to determine load of failure. Roy, do you have any experience there?
Yeah, if I understand the question correctly, there are computer programs where you can recreate the accident so that people can watch it like they're watching a movie and see what happened. And that has to be done, of course. Everything that happens in that little movie has to be backed up again by physical evidence. And a lot of times when people can visualize the crash that way, it makes it obvious to them how it happened. And once you do that, you can visualize, you can watch it from any angle, from straight above, inside the one of the vehicles, and that's a really valuable tool. And as far as reenacting, the one case in particular that I reenacted involved a long tractor trailer on a little curvy mountain road in West Virginia. It off-tracked 8 feet into the opposing lane and hit an ambulance on a run. So we got a similar truck. We got the police to block off the road, and we just drove the truck through there. And I told the driver to keep the off-tracking to as little as possible, and it still came out to be 8 feet. And it proved that the ambulance didn't have any place to go to avoid collision. And of course, we had cameras all over the place, video and still cameras. And when I arrived at trial, which was in federal court, and based on that video, my lawyer asked for a summary judgment, which means we said to the judge, this is so obvious what happened, we don't even need a trial. Would you just go ahead and rule in our favor? And the judge declined to do that. But the day I showed up at trial, the first thing that happened was that the defense admitted fault. And we're ready to go on to the second part of the trial, which is determine how much money they owed for being at fault, which was not part of my job. So I got to go home. But the reason the defense wanted to admit fault is that they were afraid that if the jury saw that videotape, it was so outrageous what happened that they would give a bigger award to the people who brought the lawsuit. So then my lawyer got there and said, well, we do want to put it on. and just said, no, we're not going to take up time on something that they've already admitted to. So the jury never got to see that videotape. But it is fun sometimes to reenact those things and really see them. What's the next question?
Is it difficult for someone just starting out in the forensic field?
I would say yes.
I would
because,
agree.
Pardon me?
I would agree, yes.
Yeah, you have to learn that whole system. In fact, I think the best way to do it is to work under the wing of somebody who's more experienced. And just start with them, start doing small tasks and helping them on the bigger ones, and easing into it over time, especially with the legal system. You can't just jump in the deep end on your own with that. So it can be difficult, but again, try to go to work for people who can teach you, because again, you can't learn this in school.
The way I started out was essentially working for an engineer, forensic engineer, and starting from the ground up, learned everything I could from him, and then moved beyond that into more specific training courses and conferences that dealt with particular issues. And I think that's key, is you can't jump right into it. You have to start slow and get more experience and sort of understand the process and the system, how it works. I think you don't want to have your record or reputation tarnished from making a mistake and having your testimony be stricken. That could be potentially damaging or fatal strike to one's career. Having your testimony excluded would haunt you for the rest of your career, I think.
Right. And I think one of the most important things when you're starting off is to not bite off more than you can chew. In other words, and that's part of our code of ethics. You should never take on any kind of job, whether it's forensics or anything else, that you're not sure you're qualified for. And that's why you got to start small and work up. Does that make any sense, Kurt?
Oh yeah.
Yeah, I mean, if you, it's like sometimes I work on a case, and say I'll find out how fast the car was going, and then the lawyer will say, well, now we've got a seatbelt question at that speed, and I go, well, I'm not an expert in seatbelts. We need to get Kurt to come in on that, and he may say, oh, we don't want to pay for another guy. I'm pretty sure I can get the judge to let you in as a seatbelt expert, and I go, but I'm not one. I'm not going to go in there and say I am one, and let the opposing attorney prove that to everybody in the place, and then the judge will never trust me again. You just have to stand your ground.
Yeah, I agree with that. You have to start small and work your way up with experience, and that experience you can be gained and enhanced through your association with another engineer who's got that experience. Another question: if you've been working as a civil engineer, just said by example, in a traditional job, how can you start to transition into forensic work?
Well, I think in a lot of cases, like I said before, they will find you. But if you want to start doing this kind of work, I would look around for somebody who's already doing it, and ask them if they need some help, if I could assist them, maybe come into their business, and especially if they want to retire, and train somebody to take their place. But in my case, it was lawyers who needed technical help, and I'm in a small town, eastern Kentucky. I don't think there's another member of the academy east of I-75, so I'm a big frog in a small pond, and so people knew about me, and lawyers came to me and asked for help. So it's probably a lot different in a big city.
The example here locally is there's a custom motorcycle fabricator that's in town, and he was called, I don't know how his name got out, but he was approached by an attorney who had a motorcycle issue in one of his cases, and this fellow had plenty of experience to render an opinion based on his background in working in fabricating motorcycles. So there was a guy who was essentially a welder, if you will, but one specific to building motorcycles. And he was brought in to analyze a particular failure in a case, and it was without question that he had enough experience to render those opinions, and he was admitted to do so in court. And then, of course, from then on, word spreads that this fellow may be kind of rough on the edges, but he knows his stuff, and he would be the one called in on the local motorcycle type crashes and failures.
Who's got a question?
I don't see any here. I'm looking for a new one.
Okay.
Can I come to the AAFS meeting if I'm not a member? And what kind of activities happen at the meeting?
Is Dr. Logan still on?
Yes.
I'm not sure if I remember. It's been a long time, but I think you have to come to some meetings before you can become a member. Is that right?
You got to turn your audio on.
Can't hear you.
Yeah, anybody can attend a meeting of the AAFS as a delegate. You can go to the website and it'll tell you how to sign up to attend the meeting. The advanced program for the 2014 meeting, which is in Seattle in February, has just gone live. So if you take a look on our website, you'll see what is planned for the engineering sciences section there. I just took a look at the program actually. Looks pretty interesting. We've got about 40 different papers that are going to be presented. Covering everything from minimizing risks from natural gas production, distribution, and use, cutting-edge legal issues and considerations surfacing from scientific processes involving fracking, tour bus limit, handling degradation with suspension modifications. So it's just a real mix of different investigative cases that people have worked on and issues that they've encountered in their casework. So you can see details of that, of the entire program on the website. I don't know, Rye, does your section do workshops or breakfasts or other sessions for the Academy meeting?
Yes, and to answer the rest of that question, during that week there are workshops anywhere from a couple of hours to all day long. There are technical papers presented at breakfast, like Dr. Logan mentioned, at lunches, and then on Thursday and Friday of the week, you go to your particular section, which in this case would be the engineering sciences, and you will have 1 or 2 rooms with people presenting technical papers all day long. And you can come to all of them or just come to the ones that relate to your particular interest. And they're always interesting. And there are other dinners and things that go on where you can meet lots of people. There are receptions. It's a great way to get to know a lot of good people in the field.
So, Cart, I see that you're presenting a paper here at the meeting on farm tractor collision.
Yes. That was a case where there was a farm tractor within a vineyard, essentially following a planting crew. Each season they pull out some of the maybe non-producing or dead vines and they replant with new shoots, and this fellow was following the planting crew with his tractor and trailer that had basically a watering tank, and he'd stop his tractor and get out and water each plant. And he came to the end of the row and made a U-turn to go back up not one but the second adjacent row and start planting, going on the upside of the rise. And as he emerged at the end of the row and made a U-turn in this road, there was a grader that had been hired to essentially grade all the roads on the vineyard. And unbeknownst to the tractor operator, and he pokes out into the road to make his U-turn, and the grader sees him, but of course doesn't react until the last moment. Tries to make steering avoidance or the collision avoidance type maneuver, and he essentially runs over the tractor, knocks it over, and the tractor operator was killed in the incident because he was run over. There was a couple of lawsuits. One was a workers' comp, and then there was the civil case against the construction company that had the grader in the area that was on the roadway at the time. That I think he had plenty of time to avoid the crash and stop before he ultimately ran over the tractor and the operator himself. Well, going back to the program, you said it was interesting, Barry. I found it very interesting. I haven't seen a program with such diverse topics, and all seem very interesting. And I'm not just pumping the academy. I saw the advanced program before it went online, and I was amazed at how oh my gosh, 4 months prior, I'm already excited about the program in the 2 days. There was just an amazing number of articles or essentially oral presentations that had that sparked my interest. It's been years since I've felt really excited about the program.
Well, I'm glad to hear that because, as you know, our section is one of the smallest, and sometimes I think a lot of the other sections don't think we're quite as legitimate as they are, since they're scientists and a lot of them are involved in crimes and things like that. But it is interesting, when you have something like a major plane crash or a bridge collapse or something like that, you want to know how it happened, especially to keep it from happening again. And it's people like us who figure it out.
Well, one of the things that I always found attractive and engaging about the Academy is the fact that it is a multidisciplinary organization. And although we have 11 sections that do have their own programs, there's also a lot of interaction between sections. So, for example, I know that engineering sciences and pathology biology have held sessions before on controversial issues like shaken baby syndrome, where you're looking at biomechanics of shaking a child and what kind of injuries that can create that might be detectable or observable at an autopsy. This year, the toxicology section is doing a joint session with the psychiatry and behavioral sciences section, talking about adverse effects of some of the newly emerging drugs. So it's, people were asking about how you get into the field and how you make contacts. Really, participation in professional organizations, both nationally and regionally, is a way to get introduced to other people in the field, to make contacts. People in our field refer cases to each other all the time. That's sometimes a way that you get introduced to new clients or new attorneys to work with on these kinds of cases. So it's a great organization for networking.
Yes, I've had cases where, for example, you may have a crash where everyone is ejected, and say it's a high-speed crash, and the people involved were known to be drinking or something like that, and so usually the driver of the car will be charged with the crime, and then he may say, but I was drunk, so I let my friend drive. I wasn't driving when this happened. And that's when you start looking at injuries. Now, for an engineer to start looking at injuries, I've got to start talking to doctors. And fortunately, I had a mother who was a registered nurse who answered all the easy questions for me. But there are times when I've had to look at injury patterns, even morgue photographs and medical reports and things like that, to just find out who was in each position in the vehicle at the time of the crash. And you may even want to use DNA sometimes to find out whose blood is on an airbag, that kind of thing. Totally outside my area, I'd have to get somebody to come help. But
yeah.
we had an engineer who was keenly interested in the shaken baby syndrome and presented some technical papers. And I wish I could think of his name right now because he's not with us anymore. But he was, and we still have guys in our section who are interested in that. And they look at the skeleton almost like a set of mechanical linkages and how they can move. to show what's possible and what's not possible when you shake a baby.
Roy, when you went through your presentation, you talked about different kinds of engineering programs, university programs that people could take that would give them an entree into the field. And it seemed like there were a lot of different options. Are there accreditations for programs that specialize in subjects that would assist somebody if they were interested in a particular forensic direction?
Well, it's funny, when I'm asked what courses I took in college that helped me do the investigation, I answer just about all of them, because my degree is in mechanical engineering, and I think I would guess that most of the engineers in our section, or at least a lot of them, are mechanical engineers, and it's basically for accident reconstruction, it's just a lot of second-year physics. So every engineer takes that, and we also study a lot of metallurgy and strength of materials, and of course we have chemistry and electricity and those kind of things. So all or any of those things can help with the case. But there, like I said, there is no degree in forensic engineering, and I think there was a school one time that was talking about having some graduate courses in that, but I don't know if that even developed. So as far as certifications, I know I'm certified as a forensic engineer through the National Academy of Forensic Engineers, and that's mostly based on experience and the number of times I've qualified in court to testify and so forth. But there's not a test for it, and they're not. I don't know of any courses that specifically address it. But one thing that the students might be interested in is when you see on television where they will run a car into a wall, that's because there's a law. Is somebody else talking? That's because there's a law that cars have to be designed so that with the 35-mile-an-hour impact, frontal impact, the average person will survive. And they have those instrumented dummies that can tell when they run those crash tests whether the person is likely to survive or not, and if they don't, they have to go back and redesign the car. Well, when they do these crashes, they measure the crush. They know the speed, they measure the crush, and once we know the crush at that speed for that particular car, if we have a crash that involves that kind of car and we know the crush, then we can work backwards and get the speed. So that's really beneficial to us. So if you have a certain amount of crush on the front of a car and then you have a certain skid mark length, we can calculate how much speed was lost before the impact, how much speed was lost at impact. Then you can work back earlier in time using human factors, which is another whole big field of study. If you look at reaction time and perception time before the person even hit the brakes, then you know where they were down the road when the whole scenario started. That's the kind of thing I really enjoy the most. I mean, I've had pedestrian cases where somebody will say, where this pickup truck hit a kid in the road, could he have seen that kid 250 feet away? And after I do my investigation, I'll say, yeah, you can see him 250 feet away, but the problem is, by the time the car covers that 250 feet, the kid's already gone. He's off the highway, unless he's just standing there waiting to be hit. So it's like working a puzzle in that respect. But I really enjoy those. Who else has got a question?
Yep, you want to take that one?
Oh, that's not something I've done. It's a good thing. It's just a higher level because it's international. And
can you read the question?
Yeah, certification by the IBFES. That I haven't even seen the application of that, but I think one of the key things is an interview by several of the members. When you apply, you have to be interviewed to show you're qualified, and probably give one of your cases that they question.
I think it's you provide a couple of reports that were filed in several cases, one or two examples, and then you have to provide 2 letters from 2 different clients who you've testified for. I think the board would then take that into consideration, and then there's the interview as well. I think it's on standards and your ethics and practicing in your field.
That's a good question. Go ahead.
We're getting close to the end of our hour here, so I just wanted to encourage anyone who's on the calls to submit any questions, maybe as we start to think about wrapping things up.
Yeah, and if you can see the screen, the email addresses for Kurt and I are both on there. And if you're like me and you think of a question 5 minutes after we quit, it's not too late. You can write us.
Okay. Well, just as I wrap things up here, I think we'll hand back to Jeff Lubbers, and he can tell us about when this will be archived online and be available to anybody who intended to participate but wasn't able to join us tonight. But I'd like to thank Roy and Kurt for coming together and putting this together for us. This is our first year offering these webinars. This is our first foray into online information offerings. The theme of our annual meeting this year in Seattle is on forensic science education and mentorship, and there's a lot of elements in the program that are designed to help people who are entering the field understand about the correct kinds of choices to make that will help them in their careers and start that process of networking and meeting other people in the field that will give you the break or the introduction that you're looking for to get into the field. So again, I'd encourage you to go back and look at the website, and hopefully that will help you in your investigations about careers in forensic engineering sciences. So Paul, Jeff, sorry, do you want to wrap things up for us?
Yeah, I just want to thank everyone for being here. It looks like we've answered all the questions that have come in. But as Roy said, feel free to email them. If you have any questions about future webinars or anything related to the Academy, feel free to email me at jlubbers@aafs.org. And I'd be happy to connect you with the right person there. This webinar was recorded and will be archived on the Academy's website under the Videos tab under Resources. It should be online, I would think, by Friday. So if you know someone who missed this who is interested, please share that information with them. And thank you very much for being here, Kurt and Roy, and thank you very much for attending, everyone.
Thank you all.
Thank you.